Hi guys, this is the spiral review for spiral 10. We're going to start out by graphing some trigonometry. First thing I'm going to do is take a look at my equation and see what I can get out of this. I can figure out my midline, and that's the first thing I'm going to graph. So midline is always what's being added or subtracted outside of the function. In this case it's going to be positive 2. I can figure out this is a negative cosine graph. That means I'm going to start at the bottom, go up, and come back down. Go through my midline twice. And more so, I can get an amplitude of 3 from this. So that means 3 above, so at 5. And 3 below, so at negative 1. Those are going to be the boundaries of my graph. Okay, that's step 1. Step 2 is taking a look at the inside and finding some beginning and end points. So for my beginning, I'm going to write that 2 pi over 12 times x minus 2 is equal to 0. If I multiply both sides by 12 over 2 pi, I get x minus 2 is equal to 0. Okay, so x equals 2. That's my starting point. Because we're looking at negative cosine, my starting point is going to be at 2 and at the bottom of my graph. In other words, at the bottom of my amplitude line. Okay. The next thing I need to do is find an end point. So that's the beginning. And do the same thing. 2 pi over 12 times the quantity x minus 2 is equal to 2 pi. This time when I multiply by the reciprocal, 12 over 2 pi, 12 over 2 pi, my 2 pi's cancel out on the side, and I've got x minus 2 is equal to 12. In other words, x is 14. Okay, this is the end point, so it's going to be on the bottom. 14 doesn't actually exist on my graph because I'm a knucklehead, so it's going to be somewhere over there. I'll put that there just so we can see it. Okay, exactly halfway between these, so 2 and 14, exactly halfway between them would be 8, and that's going to be my maximum value. So at 8 I'm going to go up to the top, and then I've got to find my points in the midline. Halfway between 2 and 8 is going to be 5. So 5 is going to be on the midline. Halfway between 8 and 14 is going to be 9. And by 9, I mean 11. And that's going to be on the midline too. My general shape should be a nice smooth curve going through these points. Next up, we've got to write an equation using both sine and cosine. Let's figure some stuff out about this. If I take a look at my graph, the first thing I notice is that it appears my midline goes through 11. And just to confirm, halfway between 7 and 15. So midline, the average of 7 plus 15 over 2, and we get 11. Nice, so that works. That's my d value. Second thing I've got to do is amplitude. My amplitude I'm going to get from looking at how high we're going from the middle up to the top, or looking at the difference of the highest and lowest points and cutting that in half. In this case, that'd be 4. So my a value is going to be 4. All right, next up we're going to look at period. And for period, I'm going to look at the x distance between 2 maximum points, or if I wanted to, 2 minimum points. But I don't have the values for those minimums, so I'll use the maximum. And going from 0.75 to 3, 0.75, I get 3. Okay, so if 3 is the period, 2 pi over b equals 3. Solving that, I get a b value of 2 pi over 3. We've done midline, we've done amplitude, we've done period. Now we have to decide where we're starting. And we need to know that for positive cosine, I'm starting from maximum, so I could choose a maximum value to start from. Since the x value there is 0.75, I could say that c is equal to 0.75. That's the x value at a maximum. For a positive sine graph, I would start at the midline going up. And my value there would be 0. Building my equation, these in general should look like a sine b times the quantity x minus c plus d. So in terms of building this, my first equation for cosine would be y is equal to 4 cosine 2 pi over 3, the quantity x minus 0.75, and then plus 11. My sine equation would be very similar. Y equals 4 sine 2 pi over 3, x minus 0, you don't need that 0, you can just write x, and then plus 11. The only thing that changes going from sine to cosine in any of these problems is going to be the midline. By midline, I mean the phase shift, and potentially whether this is positive or negative. Those two things can change. The period and the amplitude and the midline all stay constant. Next up, we're going to do a similar thing, but now we're working from a problem instead of from a graph. And here we're looking at Wei, who's standing in some waves, and we're going to try to make some sense of what's going on here. Okay, so we have after 1.1 seconds, and then again every 3 seconds, the water just touches his knees. Between peaks, the water recedes to his ankles. Okay, so knees, that's a maximum value. So after 1.1 seconds, he has a maximum value. So I'm going to say that there's a max at 1.1 seconds. If I'm going to use a positive cosine, I need to start at a max value, so that could be my c value. Okay, then again every 3 seconds. Every 3 seconds, to me that screams period, because it's talking about repeating every 3 seconds. So in this case, if my period is 3, 3 would be 2 pi over that b value. That means that b is 2 pi over 3. Okay, between peaks the water recedes to his ankles. That would be a minimum value, and Wei's ankles are 12 centimeters off the floor. So my minimum value would be 12. And his knees are 55 centimeters. Okay, that seems like a max value is 55. Let's get the rest of this information from our kind of notes here. So we're looking for a midline. We know that's the average of the max and min. So 12 plus 55 divided by 2. That's going to be 67. 67 divided by 2 is going to be 33.5, and that's our d value. Okay, amplitude we're going to find pretty similarly, but we're going to use the difference instead. So 55 minus 12 divided by 2, which would be 43 divided by 2, or 21.5, and that's our a value. Okay, we got our period, so b is 2 pi over 3. And we already talked a little bit about if we're using cosine, we're going to start at the time of the max. In other words, 1.1. So c would be 1.1 for positive cosine. Okay, we're working an equation from this. We're looking at y is equal to 21.5 cosine 2 pi over 3 x minus 1.1 and then plus 33.5. We've got to use this equation to find the depth of the water 11 seconds after Way starts his stopwatch. Okay, I'm just going to plug 11 in for x. 21.5 cosine 2 pi over 3, 11 minus 1.1 plus 33.5. When I put that into my calculator, making sure I'm in radians, I get a value of 26.856. And that would be centimeters at 11 seconds. Next up, we got some trig equations that we have to do some solving for. First thing I might do for my first guy is to clear some of this division stuff. I can do this a couple different ways. One way would be to multiply the entire problem by 3. Another way would be to do the division here. And I might do the second option. That would be a little bit simpler for us. So 3 divided by 3, I get 1. 4 divided by 3, I get 4/3 sine x. And on the other side, I'm just going to keep my 1 plus 2 root 3 over 3. Okay, if I subtract 1 from both sides, the nice thing is those pieces cancel out. I'm left with 4/3 sine x is equal to 2 root 3 over 3. I can multiply both sides by 3. Cancel, 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 cancel. And then divide both sides by 4. And I get sine x is equal to 2 root 3 over 4. 2/4 cancels out into a half, and that gives me root 3 over 2. First thing I take from this is that we're looking in the first and second quadrants, because in these two quadrants, sine is positive. Second thing is that this has to be a 30, 60, 90 right triangle, because that's the only way I can get root 3 over 2 as a sine value. In fact, this is going to be a 60 degree, or in the pi over 3 family. My pi over 3 angles are going to be pi over 3 because we're positive, and then 2 pi over 3. We're looking between 0 and 2 pi, so those are the only two positive sine values that I have for this type of, for this specific question at the end. Sorry, I lost my train of thought there. In other words, x is equal to pi over 3, and x is equal to 2 pi over 3. Those are the two values that work. For our second trig equation, we're doing some factoring. I can tell this is factoring because all of these are in the same trig function. They're all cosine. And I see something squared, something not squared, and a number. So first step, I might try to factor this. I'm looking for numbers that multiply to 6 cosine squared x and add up to negative 5 cosine x. Okay, well, things that multiply to 6, 1 times 6, well, that adds to 7. Negative 1 times 6 would be negative 7, okay. 2 times 3 would be positive 6, positive 5 rather. But negative 2 times negative 3, I get positive 6, and negative 2 plus negative 3, I get negative 5. Nice. So 3 cosine squared x minus 2 cosine x minus 3 cosine x plus 2 is equal to 0. I'm going to factor this by grouping. First of all, I can pull cosine x out. I've got 3 cosine x minus 2. The second two don't have anything in common. I'm going to pull a minus 1 out to get rid of that negative. I get 3 cosine x minus 2. Okay, I'm going to factor out the 3 cosine x minus 2. So 3 cosine x minus 2, and my leftovers are cosine x minus 1. That means that 3 cosine x minus 2 equals 0. In other words, cosine x equals 2/3. That's not a unit circle value, which is not entirely fun. And then I'm going to have cosine x is equal to 1, which is a unit circle value, which makes me a lot happier. Let's do this guy first. Cosine x equals 1, I know that only happens when x value is 1. In other words, at the point to the far right, because that's the coordinate 1, 0. For this case, x would be 0. X could also be 2 pi, but that's outside of our range of values that we're looking at. Second thing I've got to look at is cosine of x is equal to 2/3. Well, that's a positive. Cosine is positive in the first and the fourth quadrants. A value of 2/3 means I'm going to have to use some inverse trig. So this is a calculator active part. I probably will not be giving you something like this on a spiral. So I'd say cosine inverse of 2/3, and that should give me an x value. And when I do that, I'm going to get a nice decimal, and by nice I mean not so nice. So cosine inverse of 2/3, I get 0.841. Which is the positive version. To get the one that's in the fourth quadrant, what I'm going to do is think about this in terms of, okay, if I go all the way around, that's 2 pi. If I want to get to there, or 5, so 2 pi, be 2 pi minus 0.841. So I'm subtracting that original angle. So if I do 2 pi minus 0.841, we get another answer of 5.44. And again, don't love that I gave you one that involved one irrational answer, but that's okay. Next up, we got some proofs. First thing I'd like to remind us is you can only touch one side, and generally we touch the more complicated side to manipulate. I'm going to ignore the cosine of x because that's a much simpler side than the stuff that's on the left here. A strategy that we have is to convert everything to sine and cosine, and I gave you guys a nice toolbox here that gives you all kinds of identities that might be helpful. Okay, so sine x is already set up. I don't need to convert that. So sine x. Cosine x is already converted. I'm going to write that as cosine x. Tangent of x I'm going to write as sine x over cosine x. Cotangent of x I'm going to write as cosine x over sine x. Cosecant of x I'm going to write as 1 over sine x. And because we're dealing with fractions, I'm going to write these guys over 1. I'm going to do some cross-canceling. I see a cosine on the top and on the bottom. Those cancel. I see a sine on the top and on the bottom. Those cancel. I see a sine on the top and on the bottom. Those cancel. Because we're multiplying and doing nothing but multiplying, I can do that. If there had been any addition or subtraction, that is not a legal move and you will go to math jail. That leaves me with cosine of x on the left side, cosine of x on the right side, and my identity has been proven. For our second identity, we're trying to work with tangent squared, cotangent squared, cosine to the fourth, sine to the fourth. What? That's crazy stuff. Again, I'm going to use my toolkit to kind of help me figure things out. I like converting everything to sine and cosine, so we're going to make use of these guys to start off. So I would write this as tangent squared is going to be sine squared x over cosine squared x. Cotangent squared is going to be cosine squared x over sine squared x. I'm going to leave this guy alone. It's already in terms of cosine. Cosine to the fourth x, and keep my sine to the fourth coming down. All right. If I'm dividing two fractions and multiplying their reciprocals, so I'm going to rewrite this as sine squared x over cosine squared x. The bottom's going to flip and multiply, so sine squared x over cosine squared x. And we've got cosine to the fourth x equals sine to the fourth x. Okay, I'm going to combine some stuff here. So sine squared times sine squared is sine to the fourth x. Cosine squared times cosine squared is cosine to the fourth x. Then we've got times cosine to the fourth x. I'm going to write that over 1. And that's equal to sine to the fourth x. You might notice that we're multiplying two things that have a cosine to the fourth on the top and the bottom. That leaves me with sine to the fourth x is equal to sine to the fourth x, which is what we're looking for. Okay, for our last identity, we're looking at cosine cubed minus cosine x is equal to negative cosine x sine squared x. In looking at this, we are dealing with trying to work between cosine and sine. Everything's already set up in terms of sine and cosine. In that case, I'm going to predict that I'm going to have to use my Pythagorean identities. Cosine squared x plus sine squared x is equal to 1. And from there, that might give me some insight, because I know that, for example, 1 minus cosine squared x is equal to sine squared x, and 1 minus sine squared x is equal to cosine squared x. Those things might come in handy for this problem. Second thing that I notice is that both of these pieces have a cosine x. I have to be able to factor, and in this case I'm going to apply that factoring. I'm going to take a cosine x out, and I'm left with cosine squared x minus 1. And that's equal to negative cosine x sine squared x. Okay, I don't see this exact expression in my group of identities here. But I know I need a sine x. I might as well try switching out the cosine squared x using this guy and see what happens. So cosine x, that would be 1 minus sine squared x, and then I still have my minus 1 in there. And that's still going to be equal to negative cosine x sine squared x. I'd like you to notice that 1 minus 1 is 0. Cosine x times negative sine squared x is the same thing as negative cosine x sine squared x. So even though that didn't look readily apparent that those were the same thing, when I plugged it in to try to see if it worked, it happened to work. And I got something that made some sense.